Part 3 of this video series has to do with measuring cause and effect. I'm going to start by explaining a little bit where the ideas of cause and effect come from. So scientists propose hypotheses as answers to scientific questions. In other words, as explanations for phenomena or crazy observable events that happen in our daily lives. And to explain a phenomenon in science is to identify its causes. The philosopher David Hume, is this old guy from like the 1700s, argued that causation is not something we can actually see. It's just something that we can infer from seeing two concurrent events over and over again. This is an idea that he published in his treatise on human nature in 1739 and 1740. So, one example of how he might explain things, he might say, for example, each time we water the lawn, we may observe that the grass grows more than if we don't water the lawn. From repeatedly observing one event following the other, we infer that watering the grass causes the grass to grow. But the cause itself is not something we can truly witness or experience in any way. We can't see the water making the grass grow. We can only see the water go in and then see the grass grow longer afterwards. What do you and your partner think of that argument? Do you think you can see cause, or can you not see cause? In other words, do you agree with this David Hume philosopher, or don't you? And explain your reasoning on your piece of paper. Whether or not you agree with David Hume that it's impossible to see cause, it's no doubt very hard. And since it's so hard, scientists try to find a way to get at it, to sort of figure out what the cause is for something. And the way they do that is by assembling a bank of observations, which they call data, on the inputs and the outputs of an experiment. So the scientists might not be able to see the water causing the plant to grow, but they could keep track of the amount of water they give the grass, as well as the change in the height of the plant. They call the aspect of the cause they can measure the independent variable, and the corresponding aspect of the effect the dependent variable. In the grass example, let's say the volume of water that gets sprayed on the lawn is the independent variable. So you could go in and measure that. You could measure, oh, what's the volume of water that I put on my lawn? And then the resulting increase in the length of grass might be an example of a dependent variable. So you could go in with a ruler and say, oh yes, my grass blades increased by 3 centimeters or whatever. So they call these the independent variable and the dependent variable for a very logical reason. Because if the hypothesis is supported, then that means that the dependent variable depends on the independent variable. In other words, the length that the grass grows depends on the amount of water we put on the lawn. So even if we can't see the cause, at least we can measure the independent variable and the dependent variable. And if the dependent variable depends on the independent variable, then that gives us an idea that our hypothesis might be right.